Most memory diagrams just throw boxes and arrows at you. Let's use a story instead. Picture the JVM as a giant hotel. Every Java program lives inside it. 3 floors, the penthouse, the guest rooms, and the reception. A class arrives like a delivery. The class loader unpacks employee and files its blueprint up in the penthouse, the method area. Remember, a class is not an object. It's just a blueprint, stored once. Static fields belong to the blueprint, not to any object. So company equals Google goes up as a banner on the penthouse wall. One copy, shared by everyone. Now we write new employee. The word new tells reception to reserve a brand new guest room in the heap, room 101. At first it holds only defaults. ID is 0 and name is null. Then the constructor walks in and furnishes the room, setting ID to 101 and name to John. That's all a constructor does, initialize the freshly created object. Here's the idea that fixes years of confusion. The variable E1 does not hold the employee. Down at reception, it only holds the room number, 101. The object stays in its room. E1 just keeps the key. A second new makes a completely separate room, 102 Ellis, and E2 keeps that key. 2 rooms, 2 keys, 2 independent objects. Both employees still share one thing, the Google banner upstairs. That's a static variable, a single copy on the blueprint that every object can see. Call a method, e1.display, and reception opens a temporary service desk. That desk is a stack frame created just for this call. Inside the method, we declare a local variable bonus equals 5,000. It's a sticky note on that temporary desk. It exists only while the method runs. The moment display finishes, the desk is cleared away and the sticky note is gone. Local variables die with their method. Now we set E1 to null. Reception tears up the key card, but room 101 is untouched. The object still exists, only the reference is gone. With no key left, nobody can reach room 101. The garbage collector, our housekeeping robot, finds the unreachable room and clears it. That's automatic memory cleanup. Let's see the whole hotel together, the penthouse, our method area, the class blueprint, and the shared static banner, loaded just once. The guest rooms, our heap, every object made with new lives here, in its own room, with its own data. And the reception, our stack, references that hold room numbers, plus temporary desks for method calls and their local notes. That's the entire Java memory model in one picture. Question 1. Where is an object stored and where is its reference? The object lives in the heap, a guest room, while the reference variable sits on the stack and only holds the room's address. Question 2. Where do static variables live and who can use them? They belong to the class in the method area, the penthouse banner, and every object shares that single copy. Question 3. What happens to a local variable after its method returns? It's destroyed. Locals live inside the method's stack frame, so once the frame is removed, they're gone. Question 4. After E1 equals null, is the object deleted immediately? No. Setting the reference to null only removes the key. The object survives until it's unreachable, and then the garbage collector reclaims it. Question 5. What's the real difference between a class and an object? A class is the blueprint, stored once in the method area. An object is a real room built from that blueprint in the heap. One blueprint, many rooms. Now it's your turn. Take the topic test and lock it in. 5 multiple choice plus 5 short answers, graded by AI. The link is in the description below.